understand what it means to be a similar figure and what it means to have corresponding sides or angles. So similar figures, sorry, similar figures are polygons. Polygons are closed shapes. So similar figures are polygons that have the same shape but different sizes. So for instance, we could say that a triangle and a smaller triangle are similar because they're the same shape. We couldn't say that a square and a triangle are similar because they're not the same shape. Similar figures have to be figures that are the exact same shape. Now, corresponding, that means they have the same position. So for instance, Joshua and Coco are corresponding because they're in the same position in the classroom, just on different sides. Joe and Lauren are corresponding, they're in the same position. Make sense? Okay, so how do we know if polygons are similar? We know if polygons are similar if they have corresponding angles that are congruent. So basically, if they have angles that are in the same spot and they're the same angle measurement, that would be corresponding. They also have to have the lengths of their corresponding sides are proportional. This is why we learned how to figure out if something's proportional. So the lengths of the corresponding sides also have to be proportional. Everybody with me? Okay, so what we're going to try to do today is figure out if this green triangle is similar to this blue triangle. Just by looking at it, they obviously look similar. They're the same shape, right? But to know if something's similar, they have to have corresponding angles that are congruent, and the length of the corresponding sides must be proportional. So, if you notice, TPN, this triangle, the green triangle, has a right angle right here. Everybody with me? Does RKG have a right angle in the same spot? Yes. Yes. Even though it's flipped, they basically took the green and just flipped it upside down. They have a right angle in the same spot. So they have corresponding angles that are congruent, meaning they're in the same spot and they're the same angle measurement. Everybody with me? Next, what you're going to look at is the length of the corresponding sides have to be proportional. So how I do it is I pick sides that I know are the same. So what two lines are the same in the triangles, could you say? K to G and T to P. Yes, they're the same line. Does everyone see that? T to P is 16. K to G is 8, but they're the same line on the triangle. Does that make sense? So we could say that 16 corresponds to 8. Notice how they're both in the numerator position. Everybody with me? What's another set of corresponding sides that we could set up? Okay. Say it again. 4 equals 2. 4 equals 2. We need to look at the side lengths. Where are the side lengths the same? We're going to figure out another one. So 34 and 17. Perfect. This is where you have to be careful. The 34 must stay with the 16 because they're on the same triangle. So I'm going to put the 34 under the 16 and the 17 under the 8. I've set up the two proportions. What you would do is cross multiply and see if they're equal. And if they are, then we can say yes, they're proportional. So you should do 16 times 17, 34 times 8. All right. Hopefully when you did it, 16 times 17 gets you 272. 34 times 8 also gets you 272. So we can say that these two triangles are proportional and they're similar because they have corresponding angles, check, and their lengths are proportional based on what we just did. So we would say, yes, these are similar. If they're proportional, they're going to be similar. Question. All right, this is where it gets tricky. This is where it gets tricky. This is where it gets complicated. So if you're given similar figures, so they've told us these are similar, because it says, let's solve for the unknown based on the similar figures. So we know that this is similar to this. They're telling us that. Based on that, we know they're proportional. So we're going to find the unknown side length. And if you notice, here's the unknown side length, x. Everybody with me? Okay. So first, you have to figure out what corresponds with what. So let's start with x. What corresponds with x on this shape? What is in the same spot as x? What number is in the same spot as x? 15. So I know that x and 15 are in the same spot. So I'm going to say x equals 15. And they're both numerators because they correspond to each other. Everybody with me? All right. What's another pair of corresponding that we could use? What's another pair of corresponding sides? What's another pair? Coco. Yes, but I'm looking for numbers. So what numbers? 35 and 25. Does everyone see that? Okay, so 35 is with x. It has to stay with x. So I'm putting 35. 25 is with 15, so I'm putting 25. Questions on how I set that up? 5. So now all you have to do is cross multiply and divide to figure out what x is. Just like from 6 2. Cross multiply and divide. Okay, so after you cross multiply and then you divided, you should have gotten x to be 21. So it's asking, what is the unknown side length? So we would be able to say x equals 21. Pretty simple stuff. As long as you can find what's corresponding, you can do this. You just have to be able to recognize what's corresponding. Questions on, are you guys ready to do so much awesome algebra right now? All right. This one is super confusing. If I was going to do this one, I would separate them out. So I would draw a little triangle, and then I draw the big triangle, just so I can see it. Because right now it's confusing. They have them together, and that makes it super confusing. And then I'm going to label. If you notice, the little one is 3, 4, 5. Everybody with me? And then the big one is really x on the bottom, y going up and down, 12.5 on the diagonal side. Questions on how I labeled that? Yes, ma'am. All right. So now what you're going to do, we have to find x and we have to find y. So you're going to set up two proportions. I would solve for x, then I would solve for y separately. That's just me. So let's start with x. Let's start with x. What corresponds to x? What's in the same position as x on the smaller triangle? Right? 4. So x is the same as 4. Everyone good so far? All right. This is what I would not do. I would not say, okay, well, 3 corresponds to y. In this situation, that doesn't help you any because now you have 2 variables. So if I was doing it, I would say, okay, 12.5 corresponds to 5. That's what I would do because that's a given one. So 12.5 goes with x, so it has to go here. And 12.5 corresponds to 5 where the 4 is. Questions on that? Hopefully when you cross multiply, you got 5x equals 50. And then you divide it by 5, divided by 5, and hopefully you got 10 for x. Now you all try y on your own. You all try y. Tonight? Yes.